Once again, we try to visit the quality of service now as a network layer phenomenon. Initially, when we talked about quality of service, we looked at it from the perspective of quality of experience. In this module, we shall see when we talk about computer networks based on IP technology, what is quality of service? How do we define it? What is the primary motivation for it? In real world network, when we implement quality of service, what do we mean with regards to the parameters? We'd look at its various models and we'd also look at its practical variation. The references that I've chosen for quality of service include the classical Quiroz and Ross book and another book by Haojing Wong, the Packet Broadband Network Handbook. Basically, the IP packet networks, which are broadband working on the long haul, are meant to be multi service, all purpose communication platforms because they carry voice, video, and data traffic simultaneously on backhaul. In order to emulate circuit like behavior, quality of service as a terminology had to be defined, contemplated, and then implemented on these IP networks. This was intended because we do not want to give away the multiplexing and the multi service provisioning behavior of IP networks. What we want is that somehow on a single communication channel, without having to implement circuit switching, how can we implement one size fits all strategy to classify and divide the traffic on the basis of user demands? For that, quality of service necessitates that different classes of service are meted out different treatments because sometimes, such as the real time applications, implement low latency and high resilience requirements. On the contrary, applications such as elastic applications like file transfer, web transfer, necessitate that the file actually gets delivered without loss, but there should be no hard bound on the delay. As far as circuit switch networks are concerned, quality of service is not an issue at all. It is because in circuit switch networks, the number of users are given independent circuits, whether in time domain or in frequency domain, which do not interfere and compete with each other. But in packet switch networks, quality of service gets as a very important topic. Quality of service, as I said, can be looked at from layer 2 perspective and from layer 3 perspective. Well known technologies such as asynchronous transfer mode, frame relay, and XOR25 were always trying to provide some kind of services which emulate circuit switch behavior, but these were all layer 2 technologies. Being layer 2 technologies, something is obvious that these technologies are mainly based on hardware. And because of that, the implementation of quality of service gets to be relatively easier. In these technologies, the main emphasis of quality of service provisioning was confined to the agreement on certain traffic parameters between the sender and destination in something called the service level agreement or the SLAs. Similarly, how to control the traffic, how to throttle it, what should be the connection admission mechanism in case congestion starts building up at ATM switches or frame relay switches, what strategy has to be devised, and if two different networks of two different speeds are connected to each other, if fragmentation turns out to be a requirement, how should that be implemented? So these were the issues which were handled by ATM and frame relay kind of layer 2 QoS provisioning. But when we talk about the network layer, and specifically with regards to the internet protocol, the quality of service has to be defined as an end-to-end phenomenon, because the network layer is the complete path, whereas the layer 2 technologies talk about hop by hop or segment by segment quality of service. And because of that, it is quite possible that a certain layer 2 quality of service does not meet the layer 3 quality of service. So corresponding translation and mapping must be done. That is why with every hop, layer 3 QoS parameters have to be translated into layer 2 QoS. The Internet Protocol header has a specific field called type of service that provides the initial guidelines for providing the class of services. It was not very well used, and later, with the emergence of IP version 6, the TOS bits actually got their interest lost in the eyes of the QoS providing networks. But, anyways, that was one of the earliest provisioning in the IP based header services. In the IP type of service bits, there were 3 precedence bits which would provide 8 categories of service, including how to treat real time service, how to provide non real time services with latency and with packet loss. The lower precedence bits actually meant that if there is a packet with lower precedence marked, it could be given lower treatment in terms of packet drop as compared to a high precedence packet. It means if a router has 2 packets, one with lower precedence bits, one with higher precedence bits, the one with lower precedence bits would be dropped. Since IP version 4 class of service and type of service were not rigorously implemented, so the network equipment vendors such as Cisco, Precom, and the like rarely provided the precedence bit usage. Quality of service as a domain of interest for IP based networks can be categorized into 2 main classes: the integrated services way of looking at QoS or the differentiated services way of looking at it. Let's start with the integrated way, or called the IntServe architecture. The integrated services architecture looks at quality of service as a virtual circuit simulation of the lower layers, that is ATM and frame relay. And it sets up an end-to-end QoS route with fixed QoS parameters that remain unchanged for all the path on this virtual circuit. On the contrary, the differentiated services, also called DiffServe, defines several common classes of service which are each provided a different treatment. Each of these is associated with 2 main things. The first one is which queue it would be dealt with, and the other one is what would be the drop precedence on every hop. So in differentiated services, the discussion is what kinds of classes are there and how each class would be treated in terms of queue and priority mapping at every hop. Another way of looking at QoS is from the perspective of, is this QoS very rigid or it's flexible? So this is termed as the hard QoS guarantees and the soft QoS guarantees. The hard QoS guarantees actually imply that the application would continue to receive its requested quality of service with 100% surety or certainty. This means that it would give more kind of circuit switched behavior. The soft QoS guarantees imply that the requested quality of service will be provided with high probability, but since it is probable, so when there is congestion, the soft QoS guarantees might be violated.